Okay, let's start with tutorial 3. This is question 10. So question 10, you have uniform wheel on mass 18 kg. Let me highlight the stuff again. Uniform wheel of mass 18 kg, okay, and radius 25 cm, being put by horizontal force F against a step of height 8 cm. Alright, so you have your step here, and the wheel is here, alright, and then your pulling force is horizontally this way. Okay, there are some other, we are supposed to calculate the magnitude of the force F such that the wheel just begins to turn over the step. Alright, so what we need to do is to complete the free body diagram first so it's clearer for us. I'm just going to draw with a blue color arrow, thicker arrow as usual. So we draw the weight vector here. Okay, so this is weight. Alright, weight of the wheel. And then there are also two other forces. There's also the contact force on the ground, normal reaction force over here, slightly off. So this is N. Alright. And then there's also a force from the angle here, this point of contact. So let's call this reaction force. Right? So there are four forces acting on the wheel, right? Okay, so let's try to understand the question a bit more. What does it mean such that the wheel just begins to turn over the step? Okay, so what this means is that when you pull on this point here, this wheel will start to rotate about this point. And then basically this portion here will start to roll up this way. Alright? So when you start to roll up, right? So when this happens, let's write it here first. So when this begins to turn, right, you have a few things happening. One is that your contact with ground will disappear. Okay, that means your normal reaction force will become 0. Okay, so this is one thing we can make use of lah. So once we do that, right, once it leaves out, right, we can actually just ignore our normal contact force. So I will just leave it there, but essentially I want N to become 0 lah. Right, then there are three other forces involved. So you have you still have your weight, you still have normal reaction force, you still have your distension force here. Alright, so what you're trying to do is that you're trying to pull it up. That means this point, this is the pivot point. Alright, if you trace the CG of the wheel, right, this CG right now is here, right, it will roll along this point. Okay, so it will roll up, so your wheel will come to somewhere here. That's right, somewhere here as a result. Alright, so it roll up. Okay, so when you do that, you can, if you put the pivot to be this point, let me mark it in red, in blue color here. Right, if you take this point to pivot, right, you can say that, okay, so let's write it out. So taking pivot at point, okay, I can say that the torque due to R becomes 0 because the perpendicular distance between line of action R and to the pivot is 0 lah. Okay, so there's no line of action because your line of action of your R cuts through your pivot. Alright, so now the whole question can be much more simplified lah. Okay, I'm just going to erase the forces that I don't need. Okay, so I have less things on the diagram. Okay, I can remove this one. I also can remove my normal reaction force. Okay, so all I have is the torque due to the weight and the torque due to the tension force. Alright, so you can see the torque due to this force is actually rolling it this direction. Okay, then the torque due to the weight is rolling it in the counterclockwise direction. Right, so we can write our statements. We can say that, okay, summation of torque in the counterclockwise direction is equals to summation of torque in the clockwise direction. Okay, so counterclockwise is the torque due to the weight equals to the torque due to F. Okay, so when I just want it to be just lifted off, right, that means I just want my torque due to F be just big enough to overcome the torque due to the weight. Alright. Okay, so now let's do the math behind it. So once you can get to this stage, right, it's not too difficult lah. Okay, let's find for F first. F is very straightforward. F, right, since F is here, just go to draw a thicker line for F, right. So just extend. So you can see this is the line. This is the line of action. Okay, this is the line of action for F. Alright. So the distance I want is just like that. Okay, from here dot down. Your pivot is here lah. So let's write the pivot there. Okay, pivot is here. So this line here. Okay, this line here, quite straightforward. This line is just equals to, okay, just be careful because it's 25 cm radius, right? So this will become this this xf will just become 25 times 2 minus 8. So I get 42 cm. Alright, so once I have that, I can write it down at the bottom. So this will become f times 0.42. Alright, okay. Oh, what was that? Okay, the next one here, right, is a bit more challenging. Alright, next one here is your I want to find this one now for the weight, right? So this is the distance I'm after. Let me mark it out again. I use blue color now. This is the distance I'm after here. I want this distance to the pivot. Okay, how to find this distance? Okay, I'm just going to redraw the diagram to the side so it's clearer for us. Okay, so let's see. Let's just draw the angle. This is the 8 cm angle. Alright, this is 8 cm. Alright, then the ground is here. Okay, then right now I'm trying to find, okay, this is the center of the wheel. Okay, I dot down this distance. Okay, this distance you can see is r. Okay, and this distance here is also r. Okay, I'm trying to find this distance. Alright, this is let's call it xw. Alright, and I know that this height is 8 cm. So basically here, right, if you look at this triangle here, I'm going to shade this triangle for you. Over here, let's shade this triangle for you over here. Okay, this triangle here, right? This side here is r minus 8. This side is r. Okay, so I can do it this way. Why is my iPad making so much noise? Crap. Let me cue the noise first one. It's irritating me. Okay, can. Alright, then so to find this distance here, I'm just going to write it at the side here lah. Okay, so I want to find xw, right? So basically xw is equals to r square equals to r square minus r minus 8 square. Okay, so this is your Pythagoras theorem. Alright, okay, so it's summing the value lor. Okay, so this will become 25 square minus 17 square root. Okay, and how much would that be? That would be 25 square minus 17 square. 336 square root this, I get, what do I get? I get 18.33 cm. Okay, so this torque due to weight is how much? Weight is 18 kg, right? So this will be 18 times 9.81 multiplied by 0.1833. Okay, so my F is just equals to 18 times 9.81 times 18.33333 divided by 0.4. No, wait. 18 times 9.81 times 0.1833 divide by 0.42. Okay, then I get 77.1 newtons. Okay, right, let me double check the answer. I'll make sure it's correct. 77.1 newtons. Let's check. Yeah, it's correct. 77.11 newtons. Okay, so this is a step. This one is a bit, you need to eliminate two of the forces there. Okay. Alright, okay, let's look at question 11 next. This is the last question, thank God. But for this one, you all really need to try the extra questions at the back. Really important. Okay, let's look at this scenario. I have a uniform ladder of 10 meters long, weighing 300 newtons, leans against a smooth vertical wall with its lower end on rough horizontal ground. Bottom of the ladder is 6 meters from the ladder, from the base of the wall. Okay, bottom is 6 meters away. Then man stands at 0.6 meters. Man weighing 700 newtons stands at 0.6 meters above the ground. Alright, so let's look at this ladder. This ladder is 10 meters long. I'm just going to draw some dimensions here as well, so it's clearer for us. Let's just draw it here. So let's draw it here like this. Okay, so this distance is 10. Okay, CG of the ladder is at 5. Alright, so let's mark the CG of the ladder. Let's use black color. Okay, let's zoom in a bit. Alright, CG is here. Okay, so this is the width of the ladder. Okay, I need to label properly, right? Okay, so let's do it. Okay, so let's label this width of ladder. Okay, and we'll mark this distance as well. So this distance is 5 and this is 5. Alright. Then what other forces do we have? We have the normal reaction force due to normal reaction force of the weight, man's weight. Okay, so this is over here. This will be normal. Okay, normal contact force. Oh crap, no space right. Okay, normal contact force due to man's weight. Alright, that's a bit messy lah, but you get the idea. Okay, next other forces, we have a smooth vertical wall. So this wall here is smooth. That means there's no frictional force. There is only normal contact force. So I'm just going to label this as normal contact force from wall. Okay. Then of course we have normal contact force from ground. I'm going to, because I don't have space here, I'm not going to write everything in full. Okay, then there's also, now the floor is rough, there will be frictional force. Okay, frictional force will just oppose motion. So if you look at this ladder, right, this ladder has the tendency to slide out this way. Alright, so the frictional force has to be pointing in the opposite direction this way. So this is frictional force. Okay. Yeah, so this diagram is a bit complex, right? Okay, so there are how many forces? There is 1, 2, 3, 4, 5. 5 forces involved. Alright. Okay, so let's try to do this. We are supposed to determine reaction forces exerted by the ladder, on the ladder by the wall on the ground. Okay, so let's try to do this together. Alright, we're going to make use of the two conditions. Because this ladder is not moving, this is what we call static equilibrium. In static equilibrium, right, we are looking for we have two things we can use. So right now, we have static equilibrium. We have static equilibrium, EQBM. Okay, then we can say two things. We can say that net force in all directions is equals to 0. Alright, that's one. Second, we can say net torque, okay, summation of torque at all points equals 0 as well. Okay, so let's make use of condition 1 first. Okay, let's look at this diagram here, right? Let's see how many horizontal forces there are, how many vertical forces there are. Okay, I'm going to kind of highlight the horizontal forces in green for you. So horizontal forces are here. This is 1 and this is 2. And I'll highlight the vertical forces in yellow for you. So you have 1, the normal reaction force, the weight, and then normal reaction force from ground. Alright, so you can form two equations first. Okay, so let's try to form these two equations. Okay, so in the x direction, I can say that okay, I can say that NW is equals to F. Okay, NW, normal reaction force on the wall, is equals to frictional force. Okay, I can do that. Okay, or minus F equals 0. I'm going to take, okay, I'll just do the standard right hand side positive, upwards positive. Okay. Okay, so this is the way. Then this one I can maybe just write it as this. So positive, and NW is pointing to the right, so it's positive. Then we can do minus F because frictional force is pointing to the left, correct? Yeah, pointing to the left. Okay, equals to 0. Alright, so then we can say NW is equals to F. Okay, so let's just keep this in mind first so we can see what I can do with it later. Okay, y-axis forces, we can find, okay, we have normal force from man, we have weight of the ladder, we have normal force from ground. Okay, so we have this, normal force from ground being positive, then minus normal force from the man, minus away the weight, and this is equals to 0. Alright, so this is what we have lah. Okay, let's see what we can do now. Do we have enough information to proceed? Let's try. Okay, I think the net force one is also useful. We may need to take use pivots instead lah. Take different points to be a pivot. Okay, so let's try. Okay, let's take the base as a pivot first. Okay, let's mark this point here at the bottom. Let's zoom in a little bit. let's call this point pivot A, pivot ground lah. Okay, pivot from the ground. All right, pivot ground. Okay, so we take G as a pivot, right? Let's try. Okay, I'm just gonna squeeze it above here lah. Let's see, I write it. Okay, let's see. Okay, I'm gonna take it here lah. Okay, because now I have to keep on scrolling lah. Let me see where I can put it. I just put it here lah, easier. So, okay, taking G as pivot. Okay, what can we do? Okay, then we can see that three forces are giving me torque. Okay, we have the weight is giving me, weight of the ladder is giving me counterclockwise torque. Weight of the normal reaction force from the man is also giving me counterclockwise torque. Normal contact force from the wall is giving me clockwise torque. Alright, so let's write it down. We can say, okay, same thing, sum of clockwise torque is equals to sum of counterclockwise torque, right? So let's see what I can do. Okay, clockwise torque is only given by the normal force from the wall. So normal force from the wall, this force is over here, the pivot is here, so my perpendicular distance is this way. Alright, we don't know this height, but this height can be obtained from the Pythagoras relationship between these three items. So this height here, right, this h here is equals to 10 square minus 6 square root. Alright, square root. And what do I get? 100 minus 36, 64. So this is 8. Okay. Alright, so that's useful for us. Okay, right, let's write out the forces first. Clockwise torque. So this is torque due to NF equals to the torque due to weight plus the torque due to normal reaction force from the man's weight, right? So this one will be equals to, this we don't know, so this is NF multiplied by 8, which we work out over here just now. Okay, then the torque due to man's weight, it will be equals to weight of the ladder. Weight of the ladder is 300 newtons, so 300 multiplied by this distance here. Alright, so we now, the man's weight is over here, the ladder's weight is over here. What is this distance? Because this is at CG, right? Using similar triangle, right? This is just, this length here is just equals to 3 meters. Okay, because this is 10, this is 6. This is a similar triangle. Alright, so this distance here is 3 meters, right? So multiply by 3 plus normal reaction force due to man, that is 700 newtons multiplied by this distance here. Right, this distance here. Okay, again, now I also can use Pythagoras theorem because this is 6 and this is 8. Alright, so this triangle here is a similar triangle to this one here. Alright, so if this is 8, this is 6, that means this one 6. So that means the ratio, right? Okay, let's write the ratio at the side here. Okay, so this ratio will be equals to, how much will be equals to? 8 over 6 equals to 6 over that horizontal distance. So this is equals to, how to do now? 8 times 8x equals to 36. X is equals to how much? 36 divided by 8. 36 divided by 8. I get 4.5 meters. Okay, 4.5. Okay, so this is multiplied by 4.5. Okay, so now we can find NF quite easily lah. NF is just equals to 300 times 300. Come on, calculator, work properly. Times 3 plus 700 times 4.5 divided by 8. So I get 506.25 newtons. Let's check. NF. Yeah, 506.25 newtons. Okay, so 506.25 therefore equals to 506 newtons. Alright. Okay, and once we have that, we can work out okay, now we can make use of our diagram here, as in this one here. So we know N, is it NF? Was I doing NF? A, no crap, this is N war, right? Yeah, okay, sorry, my notation was all wrong. So this is N war, N war, N war. Okay, so now we can come to this equation here. Okay, we go N war equals to F, right? So we can say, so we can write now, okay, we can write this because n wall is equal to 506. That means F is equal to n wall, which is equal to 506 newtons as well. But this is to the left, yeah. Okay. Right, then what else can we do? We can find, what else could we find? Let's see. And wall. Must I really do? Oh, don't need. I can work out. Oh, I can work out ng. Okay, then from this equation here, so this is one. From this equation here, I can work out ng. ng is just equals to 300 plus 700. So I get 1000 newtons. Okay, you're supposed to work out anything only, right? Reaction force. Okay, so reaction force, you need to find the direction as well. Okay, so we need to find, now we know ng and F. So ng is 1000 newtons outwards. So let's just draw it here. ng is like this, 1000 newtons. This is ng equals to 1000 newtons. Then we have frictional force this way. Frictional force is 506 newtons, right? I think maybe you draw it the other way around. Let's me erase this. Okay, so this is 506 newtons, alright. And let's label this here so it's neater. Okay, so this is ng equals to 1000 newtons. This one is F. Okay, this way, F is equals to 506 newtons. So you can work out the resultant is over here. This is the angle to find. Let's call this reaction force from the floor, right? Reaction force from the ground, right? Ground, RG. Okay, reaction force from ground. So RG is equals to ng square plus F square square root. This will give me the magnitude, right? So this will give me how much? 1000 newtons. 1000 newtons. 1000 square. 1000 square plus 506 square root the whole thing, and I'll get how much? 1000 square plus 506 square, and square root this, I get 1120 newtons. 1120 newtons. I need to know the angle as well because it's asking me for the magnitude. So I can see that theta here, theta is equals to tangent inverse of ng over f. ng over f. So this will give me tangent inverse 1000 over 506. Okay, so let's try this again. 1000 divided by 506. Okay, then apply inverse tangent on it. I get 63.2 degrees. 63.1 degrees, that's fine. So 63.1 degrees. Alright. Yeah, so that's it. Quite complex, but this one has to be careful. You have to be very careful in drawing the free body diagram. Okay, but this one, I think definitely a go through in class. So by the time you watch this video, this is the second time you're watching it. So should be okay. I hope. Alright. Okay, thank you. See you guys.